In the Linux interrupt handler, whatever we have here is something like a top off and bottom off over here. For example, here we have seen something like a platform driver, which something like we will be having the platform driver. In this we have something like a interrupt handler, IRQ handler, and whatever be the thing that we are going to handle within this IRQ handler, which is called as a top off. And if suppose there is a complex and a huge task, it has to be done. But the thing is something like since the interrupt handler should be very minimal and less time consuming with respect to that, in order to achieve the higher performance of the system, we have to have something like a interrupt handler should be very less time consuming, and it should be very minimal as it is, as much minimal as possible. Basically, because of that, we will be having something like a bottom of concept come into picture. If suppose we wanted to handle the huge number of heavy tasks to be performed in case of any interrupt occurred. For example, in case of a network driver, we wanted to perform that the capturing of the network packet, and it has to send it up to the upper layer. All those things it has to be done. In that case, there is a huge task involved. It cannot be handled directly in the interrupt handler itself. For that, we have the concept called bottom off. Bottom off is basically making a task or pushing a task to be performed at the later stage is called bottom off, basically. And bottom off will be executed by the Linux kernel at the very convenient time of the Linux kernel. If there is no ISRs are present, or during the relaxed time, it will be get executed by the Linux kernel accordingly. And it also the bottom off will also runs the will get run with the interrupts are disabled, so that it will be on the safer side, as much very similar to that interrupt top off handling. But the thing is, it will be executed like a normal, it will be executed like a very similar to the kernel task accordingly over here. In order to achieve, we have the option something like interrupt context. Actually, whenever there is a ISR is get executed, the top off will be running on the interrupt context, and in case of a bottom off will be get executed in the kernel context accordingly. Which is very similar to the device driver layer, which is Linux kernel get executed basically in the kernel context. In the same context, that bottom off will be get executed accordingly over here. And in order to use that bottom off, there is a different techniques are provided by the Linux kernel, that we have something like a soft IRQs, we have something like a Tasklets, and we have something like a work queues. These are all the different techniques that Linux kernel is providing accordingly over here. And in order for that, something like for the soft IRQ, it's basically determined statically at the compilation time, and open soft IRQ takes care of IRQ initialization, that which will run on simultaneously on more than one CPU. And soft IRQs are very much painful to deal with it, because it has involved multiple IRQs. We are trying to achieve the maximum with the help of interrupt handling. But the thing is, by the usage of soft IRQ, it will be painful to implement, and it may affect that performance as well. Because of that, the soft IRQs are very rarely used in a Linux kernel environment over here. Most of the time, the most used options are something like Tasklet and IRQ are the most used options over here. And Tasklets are very much similar to the multi-threaded application which is running on the bottom of it. Since it is a single task, it can run, it will not run on the multiple threads, multiple CPUs. It will run only on one CPU simultaneously over here. And different tasklet may, if suppose we have multiple tasklets are running, then each tasklet can run on the another multiple CPUs, but one single tasklet can be will run on only one CPU at a time. It will not be run on multiple CPUs in case of a one single tasklet accordingly over here. And tasklets are something like a serialized manner. If suppose tasklets are pushed in one by one, and whichever is pushed first will be get executed in a first manner, and whichever is get executed in a second, and that will be like a serialized manner. One by one it will be get executed accordingly. That we will see how can we implement that the tasklet over here. And in order to do that, we have the option something like the tasklet structure we have over here, and that we can able to do that with the help of do that with the help of the declare tasklet. That makes that the tasklet name and function to be executed, and data to be passed for that function that we will be having over here. And that we will see how can we do that with the help of tasklet init. Whenever we are declaring the tasklets itself, that the declaration and initialization of the tasklets will be done. That we will see how it was done inside the Linux kernel source, that we can able to do that in the LXR over here. Yeah. Yeah. Here, for example, whenever we are doing the declare tasklet, then it does the initialization of the tasklet structure, whatever be the name by which we are giving, and that will be initialized with the value name of that structure, and that structure can be used accordingly over there. For example, that we are going to define this in our in our function. I am going to declare in our platform driver, I am going to declare something like declare underscore tasklet, which I am going to define something like a LDD task is the name that I am going to give for the LDD declare tasklet. And for example, we will be have to check for the what is in the 4.19 point, the version name, uname -r, the version name is 4.19.94. that we will check for the definition for the declare tasklet over here, and that will be something like declare underscore tasklet, yeah, which has something like a data and function to be called, that we will be provided over here. That we have something like a declare tasklet and the function name LDD tasklet handler over here, and data, it can be a null over here, that we are going to pass it to the LDD tasklet. and I'm going to declare something like the Tasklet handler, that we are going to declare something like with the functions. That Tasklet callback function is something like a void, and it will receive that unsigned long of data that it will be receiving accordingly. For that, I am going to declare a function called static void LDD Tasklet handler unsigned long over here. This we are going to define the prototype over here, and I'm going to declare above the interrupt handler. Yeah. I'm going to put a print k. It's something like kernel underscore info Tasklet get executed over here. Yeah, I just put a print, and I am going to return from this over here. There is no checking of whether the Tasklet got executed successfully or not. It basically, the function will be get executed, and it will be updated accordingly over there. And we have this, and once we got this, once we got that the Tasklet got initialized over here, and it will be added with the enabled state of atomic initialization. It will be enabled accordingly over here. Then we can use that we can use the functions called Tasklet schedule that can be used to schedule that schedule the Tasklet to get executed accordingly. For example, I am going to use that function over here, which is on the interrupt handler. Whenever I am getting the interrupt, I am going to execute the schedule that Tasklet over here with the information something like a the structure that it has to be passed, which is something like a LDD task over here. Yeah, and we are passing LDD task. I am passing to here, that we will see how it got executed, and we will see how it executes. Yeah, this is something like plus 148. It should be unsigned long argument over here. Yeah. Now it should be something like a long init, and I am going to pause something like a pause 11. I am going to pause 0 over here. Yeah, now it got compiled without any warnings over here, and maybe we can able to load that. I am going to load that platform driver over here. Now we will see insmart platform driver.ko. I am going to initialize the driver got initialized, and proc interrupts, and the LDD IRQ got initialized accordingly. Now I am going to press the button to initiate the interrupt over here. That, yeah, it's something like we got something like a whenever there is a interrupt, the Tasklet got executed accordingly. It's basically we are scheduling that Tasklet to get executed, and because of that whenever we are getting the interrupt, and during the interrupt we are making that this Tasklet to get executed with the help of scheduling the Tasklet over here. And for example, if suppose there is a huge function, huge task, it has to be done in the interrupt handler of bottom, if the top of this is called top of, and this is called bottom of handling of the interrupt, and whenever there is a interrupt is occurred, it schedules initiates the scheduling of tasklet in the top of, and then the bottom of will be executed by the Linux kernel at a very convenient time, so that it does not makes the system performance to down by handling everything in the interrupt handler. We can push the complete we can push that complete and complex processing to the bottom of, so that the bottom of will be get executed in the kernel context, and the kernel context in the kernel context, the whatever be the processing, it has to be complex processing has to be done. It can be done on the bottom of with the tasklet accordingly over here. Yeah. If suppose we wanted to schedule that in a different format, it's something like scheduling normally or scheduling with the higher priority, then we will use tasklet high schedule. Like that, we will be using the respective function, and we will be using the function to enable and disable. We can do that with the tasklet enable and disable over here. And if suppose we wanted to kill the tasklet which is running currently, then we can able to do that with the help of tasklet kill accordingly. Tasklet kill and tasklet kill immediate functions. Using that, we can able to kill that tasklet accordingly over here. Yeah. Basically, that we the tasklet will be used in case of something like the interrupt based on the interrupt. We wanted to do some processing on the kernel context, then we will be using tasklet, so that the data processing will be happen, something like a data collections or something like a data manipulations that it has to be done. Those tasks will be done inside that tasklet function, and it will be pushed to run. The tasklet will be pushed to run from the top of interrupt handling, and with the help of tasklet schedule function, which pushes that tasklet to get execute in the kernel context at the very convenient time of the kernel accordingly over here. Yeah. Yeah. Is that fine? Hello? The same way we have something like a work queue, which is something like it works in the kernel thread, and in a similar manner as it will be which is very similar to the process context, and it basically allows the user to create a kernel thread and bind the work to the kernel thread. That we can able to do that with the help of work queue, and which will be run. The tasklet will run on the kernel context, but the thing is, the work queue will run on the process context, so that it can able to sleep. But the thing is, the tasklet we should not sleep, because it will be run on the kernel context accordingly over here. And in order to use that, in order to use the work queue, we will be using the function called which is very similar to declare tasklet. We will be using something like a init work and or init delayed work or init delayed work. Differable macros can be used accordingly over here, and we can use the work structure to initialize accordingly with the help of schedule work over here. And the same thing we can able to do that with the help of same thing can be done by the schedule. It can be scheduled in the same way like same way like Tasklet. We can use the schedule work function, which can be used to schedule the work queue accordingly over here. And yeah, here we have something like a comparison when we have to use the Tasklet and when we have to use the work queue over here. And Tasklet will be used to get very low latency mechanism and a simple and straightforward manner, so that whenever we require the latency should be minimal or delayed execution should be minimal, then we will use the Tasklet, and it will run the Tasklet will run atomically in the run to complete fashion, so that it cannot be used to sleep. The Tasklet should not be sleep in the work basically. And in case of work queue, it is permitting queuing of multiple work items at the same time, and since the work queues are running on the process context, and it permits the handlers to sleep whenever required accordingly over here. And work queues will be used in a place where the deferred work need sleep, or it can be put into the sleep due to the during the scenarios. The work queues will be used accordingly in the Linux system over here. Yeah. Is this fine on the bottom of handling?